This lecture covers the lunar phases. As I perform this lecture in class, I pause at the beginning of the lecture and I have my students complete an activity called the lunar phases exercises. I will be referencing that activity as I go through this lecture. If you watch the moon over the course of the month, the most obvious behavior that you see is that the moon goes through a set of phases. So now we seek to understand the lunar phases. Okay, so I'm going to demonstrate right off the bat two of the main lunar phases for you. There are 8 lunar phases that are named. I'm going to demonstrate, first of all, new and full moon. I'm going to do so by doing the following. I'm going to use this light bulb here to represent the sun. I've blocked it off with some paper to reduce the glare. I'm going to use this large ball here to represent the earth. I'm going to keep it stationary here on the desk like so. And then I'm going to use this small wooden ball here to represent the moon. Let me turn off the lights. Okay, now throughout this description of the lunar phases, we're going to be ignoring eclipses. We'll get to eclipses a little bit later on. As I model the situation here, and as I begin to draw it out on the board behind me, this is all definitely not to scale. Okay, so first of all, new moon. New moon occurs when the moon is positioned here in its orbit about the Earth. And by the way, the only way to explain the lunar phases is the fact that the moon orbits the Earth. The ancient Greeks, for example, were well aware of this. Okay, now for new moon, as I said, let me go ahead and position the moon here. And as I said, for now, we're also ignoring eclipses. If you happen to be standing here on the surface of the Earth and you look towards the moon is in the sky, but you're not going to be able to see it because it's just simply too dim. You're basically looking at the entire night side of the moon. Therefore, we refer to this as new moon. Okay, and then 2 weeks later, let me go ahead and move the moon to here in its orbit. Once again, we are ignoring eclipses. We'll get to that a little bit later on. But if the moon is here in its orbit, if you're standing here on the surface of the Earth and then looking towards the moon, you're going to see the entire day side of the moon being lit up. So then therefore, we refer to this as a full moon. So where the moon is in its orbit about the Earth not only determines its phase, but as we'll see a little bit later on, it also determines what types of day you can see it. Okay, let me begin to draw out the situation here on the board. Okay, so as I said, as I draw the situation here, this is all definitely not to scale. Okay, so let's say that this right here represents the moon's orbit about the Earth. Let me go ahead and position the Earth right here on the diagram. Now let's say that by definition the sun is to the right-hand side. For now, for all practical purposes, you could picture the sun as being infinitely far away. And then we have the sun's rays coming in parallel to each other like so. Okay, now on my Earth, let me go ahead and divide it up in the following way. Right here is the night side of the Earth, and then here's the day side of the Earth. Of course, when I draw this diagram, it's from a vantage point as if we can get thousands of miles off the Earth and then look back at the situation now as the moon orbits the Earth. Okay, let me illustrate first of all new and full moon. Okay, let's position the moon here in its orbit like so. And then from our vantage point here, thousands of miles out in space, here's the night side of the moon. And then here's the day side. However, if you happen to be standing here on the Earth and then looking towards the moon, then you're going to see the entire disk of the moon in darkness. You're looking at the night side of the moon like so. This is what it looks like in the sky. This right here is new moon. Okay, now on this diagram, let's assume that the moon here orbits counterclockwise. If this is the case, by the way, the Earth, as it rotates from west to east, is also rotating counterclockwise on its axis like so. Once again, this type of motion is referred to as prograde. At any rate, however, a couple of days later, let's say that the moon is here. Here's the night side, and here's the day side. However, if you are standing on the Earth looking towards the moon, you're going to then see that right here on the right-hand side, a little bit of the moon is lit up, and on the left-hand side, it's in darkness. So it looks like this in the sky. like so. And then we refer to this situation as waxing crescent. I'll describe what the word waxing means in just a few minutes as I get towards full moon. Okay, and then a couple of days later, the moon is here in its orbit like so. Once again, here's the night side and here's the day side. However, if you were standing here on the Earth looking towards the moon in the sky, you would see that the right-hand side of the moon is lit and the left-hand side is dark. So it looks like this in the sky as seen from the Earth. This is referred to as first quarter. Okay, a couple of days after that, the moon is here in its orbit like so. And now imagine standing here on the Earth and looking towards the moon like so. You'll see that most of the right-hand side of the moon is lit and a little bit of the left-hand side is dark. It looks like this in the sky. Like so. And this is referred to as waxing gibbous. And then, a couple of days after that, here's the second portion of my demonstration from earlier. If you were standing on the Earth looking in this direction, you would see that the entire disk of the moon is lit up. You're looking at the entire day side of the moon. Therefore, you would then see a full moon. Like so. The word waxing is used to describe the following. As the moon goes from new to full, it's getting brighter. We refer to that as waxing. And then in just a few moments, as we go from full back to new once again, then the moon is getting dimmer. That's referred to as waning. So then therefore, a couple of days after full moon, the moon is here. And then this situation here is referred to as waning gibbous. Here's how we'll picture it. Now you have to use your imagination here a little bit. Imagine standing on the Earth right here and then looking in this direction. You're going to see that most of the left-hand side of the moon is lit up and a little bit of the right-hand side here is in darkness. So it's reversed of waxing gibbous. It looks like this in the sky. Like so. And this right here is referred to as waning gibbous. A couple of days after that, the moon is here in its orbit like so. Now you have to picture yourself upside down here on the Earth like so, looking in this direction. When you do, you'll see that the left-hand side of the moon is lit, and it's the right-hand side that's in darkness. So it looks like this in the sky. Like so. Notice that this is reversed from earlier with first quarter. This right here is referred to as third quarter. It's sometimes called last quarter. And then lastly, a couple days after that, the moon is here in its orbit like so. And now imagine being on the Earth right here and then looking in this direction. You'll see a little bit of the left-hand side of the moon is lit, and then most of the right-hand side is dark. So this is the other crescent. Looks like this in the sky. Like so. And this right here is referred to as waning crescent. And then we are back to new once again. The total amount of time to go through a set of lunar phases, the original definition of a lunar month, is about 29 and a half days. 29 and a half days to go from new back to new, for example, once again. 1/4 of the moon's orbit is the original definition of a week. So it takes about 7 days to go from new to first, 7 days to go from first to second, or first to full moon, excuse me, and so on and so on. So that's the original definition of a week. Now, as I went through this description of where the moon is for the particular phases, hopefully you began to notice that as I referred to a position on the Earth, where the moon is in its orbit also determines the times of day that you can see it. So then in part 2 of this lecture, I'll go through that. Let me go ahead and pause this here as part 1.